Hi guys, welcome to this class. Today we'll be learning a fundamental topic in mathematics, number bases. These are basically systems used to represent and count numbers using a specific set of digits and place values, okay? So how do I mean? So we got a specific set of digits and place values. What do we mean by a set of digits, a specific set of digits? Now, let's take an example in the natural base of numbers. The natural base of numbers. Now, the natural base of numbers is the base 10. Let me write that here. Natural base is base 10. And that's why we don't write base 10, okay, because it's just a natural base of numbers. Say in your basic math, while you're coming up, we didn't see stuff like 512 base 10. No, because it's the natural base of calculations, the natural base of numbers. What do we mean by a specific set of digits? If you pick up your phone pad on the number pad, you find out that you only have numbers from 0 to 9. So in base 10, we have numbers from 0 to 9. So this is one of the basic laws of number bases, that the number base itself cannot appear in the set of numbers. So we have 10 digits, 10 basic digits in base 10 from 0 to 9, counting from 0. Okay, we always count from 0. Take note of that. We always count from 0. So counting from 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits there. But we find out that the number 10 itself does not have a specific entity. 10 is just a combination of 1 and 0. And you see, if you notice, if you take notes, you find, okay, 11 is 1, 1, 12 is 1, 2, and so on and so forth, because 10 cannot appear in base 10, all right? And the same goes for the binary. So we've got something called binary numbers, which is base 2, basically. So in base 2 also, we have, in base 2, we have zeros and ones. We have 2 digits there. You find out that we have 2 digits. 2 cannot appear in base 2. So you understand how base 3 will look, yeah? Base 3 will be 0, 1, 2. 3 cannot appear in base 3. And how many digits are there? 3 digits. That is one of the first laws of number bases, that they are bound by a set of digits that we combine together to work under that specific base. Number 1, the base number cannot appear in that base, and there are just a set of numbers that we can use. So if you have base 3, we know that we can only use a set of 3 numbers, 0, 1, and 2. We have base 5, we've got 0, 1, 2, 3, 4. 5 cannot appear in base 5. Once you see 5, understand that's not base 5. That cannot be base 5. And how many digits are here? 1, 2, 3, 4, and 5. All right? That's one of the first things we must take note of. We have a set of digits. Then we have to understand what we mean by place values. Let's go back to fundamental math. Place values. So last time I mentioned a number, I used 512. So we go 512. In basic math, we say 2 is ones or units. Some people call it units. While 1 here represents the tens and 5 represents the hundreds. The hundreds. If you take a close look at this, I mentioned the other time that the natural base of numbers is base 10. Keep that in mind. The natural base of numbers is base 10. So let's write it as though we are writing it with base 10. We have 512 base 10, right? So this is what we do. We indicate their places. We use, say, 0, 1, and 2, right? So this is what we do. We say 512. So we say something like this: 5 multiplied by 10 raised to the power of 2 plus 1 multiplied by 10 raised to the power 1 plus 2 multiplied by 10 raised to the power 0. Okay? Watch this now. So we've got 5 multiplied by 10 raised to the power 2 is 100 plus 1 multiplied by 10 raised to the power 1 is 10 plus 2 multiplied by 10 raised to the power 0 is 1. Okay, so we notice a pattern here. Okay? So we see 100 here, and we see 500s. We see 10 here, and 1 is in the tens. We see 1, and we see ones. So The base of a number determines its place value. It is because we are calculating in base 10. That is why 5 is in hundreds. So if you're calculating in base 3 or base 4 or base whatever, it will not be in hundreds. The value of that number will be with respect to the base. Okay, let's take an example here. Let's assume we are calculating in the base 4. Let's say we are calculating 512 in the base 4. Can we do that? No. Why? Because 5 cannot appear in base 4. Even 4 itself cannot appear in base 4. So this is impossible. So let's correct that. So let's say we are calculating 313 in base 4. And I want to understand the place value of each of these numbers. How do I do that? How do I go about that? I'll say 3 multiplied by, remember our 0, 1, and 2. In this case, we have 0, 1, and 2. So I'll say 3 multiplied by 4 is equal to 2, plus 1 multiplied by 4 is equal to 1, plus 3 multiplied by 4 is equal to 0. So this gives me 3 multiplied by 4 is equal to 2 is 16, plus 1 multiplied by 4 is equal to 1, which is 4, and 3 multiplied by 4 is equal to 0 is 1. Any 3 is equal to 0 is 1 according to the laws of indices. So the place value of this 3 here is 16. So we'll just say 16. We can call it 16. The place value of 1 here is 4. And the place value of 3 here is 1. We essentially need this knowledge while we are trying to learn how to convert from one base to base 10 and so on and so forth. This is basically how we're going to do it. But let's not skip process and take it step by step. All right. I hope you understand what we mean by place values now. Let's understand how to add and subtract bases. To do that, I would love that we first calculate in natural base, which is base 10. So let's say we've got 844 plus 658. I'm not going to put base 10 there. You understand that I'm calculating the natural base. So plus here. So what we used to do while we were growing is that we say 4 plus 8, 12. So write 2 and, add 1 to the next line, basically. So we say 4 plus 1, 5 plus 5, 10. Write 0 and add 1 to the next line. So we say 8 plus 1, which is 9, plus 6, which is 15. So write 5 and, add 1 to the next line, which we can also usually write 15. Yeah? All right. Now, this was the easiest way for us to learn it while growing. But actually, what we do is that we follow the addition and subtraction law of number bases. What we do in essence is that we say 844 plus 658. So we say 8 plus 4, which is 12. But remember that a number higher than 9 cannot appear in base 10. Remember that? A number higher than 9 cannot appear in base. So I cannot write 12. There's no entity for that. So what I do is I say 12 divided by 10. This will give me 10 will go in 12 once. So 1, remainder 2. I will be left with 2. So I write this remainder 2 and I add this 1 to the next line. 1. I add this again and this gives me 10. 4 plus 1 is 5 plus 5 is 10. So I say 10 because 10 cannot appear in base 10. I remember saying that earlier. So I say 10 divided by 10. 10 will divide 10 once and we'll be left with nothing. So remainder 0. I write this remainder 0 and I add 1 to the next line. It looks almost exactly like what we used to do, yeah? But this is the basic law that binds it. But this was the easiest way for us to learn it when we were much younger. So we say 8 plus 1, which is 9. 9 plus 6 is 15. So I write 15 divided by 10. 10 will go in 15 once, and I'll be left with 5. So I write a remainder 5, and I add 1 to the next line. Okay, we don't have the next line there. So I add 1 to basically nothing. So 1 plus nothing, which is 1. So we have the same answer. You see that? So this is how addition works. in number basis. Before we go, let's just take an example. We have to add 1, 1, 0, 1, 1 plus 1, 1, 1, 1. Right? So what are we going to do there? We're going to write 1, 1, 0, 1, 1. Now, because remember, if I don't add base 2 there, I can assume it's base 10. Anybody can assume it's base 10 if I don't have base 2. If I don't have the 2 there, because base 10 is natural base of numbers. So remember to always add it. So 1, 1, 0, 1, 1 base 2 plus 1, 1, 1, 1 base 2. So we have 1 plus 1, which is 2. Now remember, 2 cannot appear in base 2. Remember that? Yes. 2 cannot appear in base 2. So what do? We say 2 divided by 2. If you go ones, remember 0. So we write 0. And add this 1 to the next line. Right? So 1 plus 1 plus 1, 3. 3 cannot appear in base 2. So write 3 divided by 2. 2 will go in 3 once. Remainder 1. So write the remainder 1. And add this 1 to the next line. So this is 2. This is 2. 1 plus 0 plus 1 is 2. We have it here already. So write the 0. And add the 1 to the next line. And we have 1 plus 1 plus 1, 3. 3. We have it here already. So write 1. And add the 1 to the next line. This is 1 plus 1. We have it here already. 2. So write 0. And add to 1 to the next line. So the answer will be 1, 0, 1, 0, 1, 0 base 2. Thank you for joining this class. This is just an introduction to number bases. We'll take more examples in subsequent videos. Ensure to subscribe and turn on notifications to get updates when new lessons are uploaded. Alright, bye-bye.